All right, so using the aVOR app on the iPad, I'm going to create that same scenario that we just talked about. So I'm going to make a dysfunctional lateral and anterior canal, and then BPPV present in the posterior canal on the same side. So that would indicate a right superior nerve problem, but then the inferior nerve is intact, innervating that posterior canal. So we can still get BPPV in that. So let's take a look at what that looks like if it's acute, if it's in the acute stage. So acutely, just sitting there, the person's going to have this resting nystagmus. You see that this nystagmus is present at rest. And if you look at the representation of the canals on the right side, you can see that that anterior and lateral canal or horizontal canal are green, so that indicates that they're inhibited. Remember, those two canals are innervated by the same nerve, but the right posterior canal, if we look at it over here, it has this little black ball right there that indicates otoconia, so that's supposed to be BPPV. Now, if you also notice, when I whisper, you see that cochlea lighten up? Loudly, you can see how dark it gets. So it's actually picking up my audio, and the person's hearing me right now, which is pretty cool. All right, now let's take this person into a Dix-Hallpike test. So you can take a look at that eye on the bottom left. I'm going to put him in the right Dix-Hallpike position. We're about to get there. Take a look at that eye and how it changes when I get him back. Okay, and also that black dot right there, you're going to see that starting to move because that's the particles or the otoconia. So let's go back. Dix-Hallpike, right Dix-Hallpike. Oh, look at that upbeating torsional nystagmus. And as that little black dot starts to settle, the eye goes back to exactly where it was. So you can see how it changes. And then it goes right back. So if that person has spontaneous nystagmus, you'll see it change if they have BPPV. And then it'll go back to that spontaneous nystagmus.